Hi, I'm Alex Griffith. I'm the team leader of the Investigation of Biological Properties of Curcumin project. This is our Summer 1 update.
I'm Hadassah Harisha.
I'm Hadil Darwish.
I'm Jemina Sawarabo.
And Heidi Mohammed could not be here today. She's in Egypt.
We are so interested on the study of the curcumin because there are a lot of health benefits related to it. Curcumin can treat inflammation. Next, curcumin can improve your skin health because it has antioxidant and anti-inflammatory properties. Research shows that curcumin can treat and prevent a lot of diseases such as cancer, diabetes, Alzheimer's, and heart disease. Curcumin can reduce allergies. It also has antimicrobial properties. On top of this, curcumin has a powerful absorbent of the ultraviolet radiation. That's why our main objective is to make sunscreen that will not stain your skin. So to do so, we try to modify the molecular structure without modifying its properties. I will leave you with Hadi, who is going to explain the process.
Okay, so we set up a fermentation process using pure curcumin. We have two samples. One sample is curcumin reacted with yeast, and another sample is curcumin reacted with ADH, which is an enzyme found in yeast. We let this ferment for 3 days, and we found that there's a distinct peach smell. And we suspect that that comes from yeast reacted with curcumin. So we repeated this whole project to see if this peach smell is in fact replicable, and it was. So updates from Summer 1. In Summer 1, our main focus was on making a sunscreen that is made by using curcumin extracted from turmeric powder. But now we are working on analyzing and studying this new compound that we think is reduced with the help of yeast. And we studied that, and also improvements we have made are cutting down the number of variables in our experiment. For example, dowside, which is an antimicrobial ingredient found in our buffer. And also we ran samples with and without sugar, and we found that there is no difference. So we just cut that off from our solutions.
So who needs sugar? We don't, because the reaction is sweet enough. So as we've learned, that curcumin can replace sugar as the carbon source for the yeast reaction.
You can use the clicker if you want. I set it up for you guys.
Oh, okay, thank you. So there are 3 main types of testing we've done. Antimicrobial testing, where we've learned that curcumin is extremely effective in inhibiting the growth of Bacillus subtilis, a gram-positive bacteria. We also use the HPLC to analyze the polarity of our compound at a certain wavelength. And we also use the UV to be able to see the different wavelengths of absorbance of our compound, where Alex will go into the more details of the results of our compound.
So what you see here is basically a graph over time of the concentration of those 2 vials you saw in the beginning of the slide. So we have curcumin with yeast and curcumin with ADH. Basically every 40 minutes we take a sample and we observe its wavelengths and its changes. So we see this trend, curcumin falls, everything else sort of raises in relation to curcumin. So we also saw this trend using HPLC, so we've confirmed this trend using 2 different means, using 2 different methods. And the most important thing you see here is that ADH and yeast perform the reaction the same way, which means we can just use yeast, which is really good news for Lewis because ADH is really expensive. So I also spent a good deal of time at NJIT in their chemistry lab using their LCMS instrument, which basically detects the mass of a compound in solution at a certain polarity. And what I found was a big mess most of the time. We did find a mass of 372, which is the mass of this, which is what we were expecting. However, it was in pretty low concentration, so we know that the reaction only produces it in small amounts and produces a lot of side effects. However, the big problem I faced with this is that the machine and all the stuff that can run this data is at NJIT, which means to extract this data back here, I have to extract every single sliver of this separately in like a text file. So going through that is incredibly painful. So it would be really nice if we could have one of these here. So our future goals are to basically fix this reaction. What we have is workable, what we have is publishable, we have a lot of really good data, but we would like to clean up this reaction a little bit more and make it more efficient. We would also like to use this fruity compound in a sunscreen because we have found that this new fruity, peachy, fun compound is just as effective as curcumin in a sunscreen when you take concentration into effect. So You can contact us at curcuminsa116@gmail.com. We're in SA116 downstairs if you want to visit us for the next week. Thank you very much.